There. Yeah, we're live. Hello, everyone. Welcome to another virtual session. You are watching YouTube Live. We are from Java User Group Bangladesh. I'm Bazlur, your host. I'm from Dhaka. Where are you from? Let us know in the comment section. In the top right or bottom right corner of your browser, where you are actually watching the YouTube, there is a chat section. So you can write there. You can ask question as well. We will try to answer your question as much as possible. Today, we have a special guest, Nicolai Parlog, joining us all the way from Germany. Hey, man, how are you doing?
Hi, I'm fine. Thank you very much. Thanks for having me.
All right. What is the temperature over there? Is it good?
It's 6 in the evening. Sorry, it's 5 in the evening.
Oh,
Um,
yeah.
and I'm actually charged with my daughter, of my daughter. So just in case I have to run out for a minute, now you know why.
Okay, no problem. All right. So, those who already joined us earlier, you already know what we do here. We do meet up virtually bi-weekly and we talk about Java. Well, today we're going to talk about what's next in the Java. Its release system. As you know, Java has now 6-month release cycle, which is pretty exciting. And there are a few more upcoming projects like the Valhalla. What do we say? Valhalla.
Valhalla, yeah.
Valhalla, yeah, and Ember, and it's lots more. So before going to the session, let me introduce Nikolai first. He's a Java developer. He's also a blogger. He has a fantastic blog named CodeFX.org. You can go there and read a lot of articles. I'm sure you'll like it. Mm. And many of you already know his blog work, I'm sure of that. He is an author. He has a great book on Java module system that you can buy. He is also an trainer. Especially, he has a great YouTube channel. He is doing a series on effective Java, which I like a lot. In fact, I eagerly wait for his new episode. So I'm sure he has a plenty of knowledge, ideas, and experience that we can get benefited from. So without further ado, let me give it over to Nikolai. So, Nikolai, shall we?
Yes. Wow. Thank you very much for the kind words. I think it was the best introduction ever. um, yeah. So you can see me. Can you also see the slides? Let's just get going. So
Yeah, slide is fine.
great. So we got a lot to talk about. This is more than an hour, this talk. So we might skip something here or there, but slides are online at slides.codefx.org. If you look at the right, top right corner, you see Java Next. So you can follow along in the slides at home if you want. And you can also see the sections that I'm skipping then. Okay, so what I want to talk to you about is the last couple of versions of Java that came out and the features that they had and where they came from. Then I want to take a step from the old world to the new world with faster release cadence and different licensing. And then in the end, we're going to come to the projects that are on the horizon and that are bringing new interesting things to Java. Let's get going with features and versions. Well, usually I do this kind of thing as a back and forth between me and the audience, but we're kind of limited here. So on that channel, so I'll talk you through this. So this is about Java 8. That's the most, let's say, I think that's the release where for me Java really began releasing versions. I didn't really realize that Java released versions before Java 8 came out because I, by coincidence, never programmed while a new version came out. And 6 and 7 are so small the differences that when I was a noob back then, I didn't realize. I didn't see the difference. So Java 8 to me is the beginning of Java version history. It was released in March 2014, and free support ends in January. So if you're still in Java 8, you should find a way. You should look into support somewhere, free or commercial. We'll come back to that in the future. So what's the core of Java 8? This is where usually the audience says something like lambda expressions and streams, and then takes a little more work to get out of them default methods. These, I think, are the core of Java 8. And when Java 8 came out, I was really happy. It's like, as I said, it was the beginning of the Java version history for me because it was like the Lambda was this new thing that I never heard about before. It was so interesting to find that out. So everybody was kind of happy. But where did Lambdas come from? Java 8 was released in March 2014. Did someone at Oracle sit down in January and just, write a couple lines of code and there we are? No, of course not. That's not how it works. This has been a long project. The project was called Lambda. In the background here, right? That's a Lambda. So Project Lambda was led by Brian Getz. It ran more than 3 years. Sorry, more than 4 years. Yes. from the end of 2009 to the beginning of 2014. There are a couple links in the slides here to the project page, the JSR, the mailing list. And the mailing list is really interesting because this is a huge discussion about every detail you can that was ever considered for the Lambda and Stream and optional APIs you can find in there. There are tons of discussions about everything. Like reading this is a monumental task, but it's really interesting. Brian Getz gave a talk, a peek under the hood, which I can highly recommend if you want to learn more about how Lambdas work. So how did Project Lambda really evolve? It launched in the end of 2009, as I said, with kind of like a strawman syntax. Like, look, this is a Lambda maybe, and we want to have something like this, so something along these lines here. What can we do? And so this was explored for almost 2 years, and then there was a first early draft which introduced the syntax that we know now. This is what eventually became Lambda expressions. But even from 2011, even after 2 years, there was more work to be done. So it takes a second and third review, and finally a public review, and then the final ballot right before Java 8 came out. So this is the process that was behind the Lambda expressions. And we're going to look at that for a couple other features as well. So the idea is that we learn a little bit about how these projects work, so we can later better understand what Project Valhalla and Amber, what they are about and how they work. So projects generally start with an idea as the strawman syntax for lambdas that you just saw. And then the idea has then evolved over years, sometimes just a few years, sometimes almost a decade. And this process is fairly open, that you can follow a lot of it along on the mailing list. There are now talks are being given way earlier than the past, I think. So it feels like it's fairly easy to follow along what happens. So that was Java 8. Let's go to Java 9. Was released in September last year. There's free support is already over. So if you're one of the very few people who moved to Java 9 but didn't move to 10 or 11 yet, then you should really do that. What's the core of Java 9? Of course, the module system. This is the module system. And this is a spot where I give you a small introduction to the module system. But this is one of the things I'm going to skip, unless later we figure out that there was a lot of interest, then maybe I can come back to this. Let's move over more JPMS. How did the module system come to be? That's the question now. Where did it come from? Many more people know this than the thing about lambdas. Project Jigsaw is kind of infamous for taking so long. So most people know that Project Jigsaw was the one that brought the module system and many other things in that vicinity into the Java ecosystem. It was led by Mark Reinold. This one ran for 9 years almost. Also, there are also tons of links here. Once again, there's a mailing list with huge amounts of information about basically everything you can imagine that touches on the module system. There are a couple of interesting talks. As early as 2015, you could see talks that were very close to what we eventually got. These are in order from 0 to 3, so you get an introduction on motivation and then a general description of how it works. So these are really great talks that you can listen to, that you can learn about the stuff before it's out. And these talks are usually held by people working on the team. These ones are linked here, are mainly by Mark Reinold, Aaron Bateman, and Alex Buckley. So these three guys have been working, well, one of the three guys working on Project Jigsaw. And if they give these talks, you know that there's good information in there. And it's a great way to learn about these things before they come out. So about Project Jigsaw, it's a fun little story in the beginning here. There was a quote from Mark Reinold. This is a quote from Mark Reinold's announcement in the end of 2009. Sun's primary goal, in the end of 2008, Sun's primary goal in the upcoming JDK 7 release will be to modularize the JDK, which we hope to deliver early in 2010. And I just love this quote because there's so many things that didn't work out. So first of all, Sun didn't work out. Then JDK 7 was not upcoming. It took another like two or 3 years even before it came out. The Jigsaw is not, the module system is not just there for the JDK. It's modularized the entire, can modularize applications as well. And none of this happened in 2010. So this goes to show you that, of course, a lot can evolve in the time that these projects run. A lot of new information can pop up, and it can take way longer than expected. We have Jigsaw history, not that important. The important part is this. This is what happened when, in the end of 2015, I think, yes, Oracle came out with a prototype. The community was not that amused. There was a lot of very critical feedback. And so that was mostly taken into account. That's the reason why Project Jigsaw took longer and longer. That, of course, an impact on Java 9, which was originally planned for the end of 2016, and then was delayed once, twice, thrice. Then finally, in the beginning of 2017, could the public review be held. So the delay of Jigsaw caused the delay of Java 9. And that is something that we've been used to in the past. The delay of Lambda causes a Lambda 8 release date to slip, and delays in the Jigsaw project Jigsaw led to Java 9 being delayed. That was common in the old model. This was what happened during public review ballot. That didn't work out that great because the review ballot fails. There were some fundamental changes requested, but there was, of course, no time to implement them. So a month later, the reconsideration ballot passes, even though there were no major changes. So you can see that some people voted against this change in May and voted against them for them in June, even though not that many things changed. So you can see some. I think my analysis is you can see some politics going on here. Because these projects, they're large and they're important. They're important for the entire ecosystem, and it's only natural that people fight over them. And then sometimes you feel that there's politics going on in the background, because this is important to a lot of people out there. So this can lead to very heated discussions, but usually feedback is taken into account. And if new requirements come up and are deemed important enough, then they are addressed and then changes are made. But that process is not, why I said earlier, it is open. It's not as open as it could be. For example, sometimes really hard to understand how a decision was made or why. The decision may eventually be announced on the mailing list, but it's not always quite clear how they got there, which would of course be interesting. So I think that could even be better, but it's already quite good. I think you can have a lot of insight into what's going on. And the last line, the most important one, maybe this can take very long time and can delay Java releases. That was what happened in the past. Now we come to Java 10, which was released just 6 months later. This is maybe the prototype, the first 6 months Java release that ever happened. Free support ended in July. So also here you have to find a new version. What's the core of Java 10? Local variable type inference. The left-hand side where you can use var instead of putting list of users there or array list of user. And then there's also application class data sharing. Not really a core of Java 10, but it's a pretty cool feature. And that's a link to a description. If you want to improve your application's launch times, then have a look at this. So local type variants. This would be the part where I explain var, just like the module system. I'm going to skip that. You can have a look at this. Here I wrote articles. I published something on YouTube, so there are tons of sources to learn about this from me and from others. But the very short gist is that we used to write code like this, for example. So we declare a variable of type URL, name code fx, and we assign it a new URL. And then, of course, URL is kind of duplicated between these two sites, right? On the right-hand side, you say new URL. So, of course, it's going to be URL. What else can it really be? Well, it can be an interface like here, but still, it's very related, obviously. This is a super type always of what's on the right-hand side. So we're repeating a lot of type information on the left and on the right. In Java 10, we don't have to do that anymore because we can now do this. We can put var on the left-hand side, and the compiler will infer the type. So there's no runtime component to this feature. This has nothing to do with dynamic typing. The compiler still does all the type checks, and it writes the type that it infers into the bytecode. There's a couple of rules, and then then we can discuss readability. Because the question is, doesn't it harm readability? And the argument is no, it doesn't if you use it right. But I'm going to skip all of that just like the model system before. I want to leave you with a slide on var, where all the links are given to the various things that I just said, like my YouTube videos on them, but also the cheat sheet, which is just great. Like when you start with Java 10, that should be if you only have one link to click that one. That's cheat sheet made by Simon Maple of the BJUG that we created together with Stuart Marks from Oracle, who worked on var, and they created a small cheat sheet which has all the important ways how to use it and where to use it and where not to use it and what to take care of. That's a great resource to get started. Where did var come from? Var came from Project Amber. And we're going to discuss Amber later. Let's move to Java 11. That's the most recent release. Free support still free support by Oracle ends in January. We're going to look at that in more detail later. And there's also no free long-term support, although that also is not entirely correct anymore, but also we'll see that later. So what's the core of Java 11? It's kind of tough. There's not really that much in there. You can launch a source code, a single file source code program like this. So if you have all your code in Hello World, you can throw the source code file at the VM. The VM will compile this into memory, will run the bytecode from memory. There you go. You've just saved half the work from source code to running application. And there's a reactive HTTP2 client, which I wrote an article about, actually two, which I can recommend the articles as well, but I was going to recommend the feature. It's really great to look into that if you want to see how in the future we can use a Java API, a JDK API, to reactively deal with HTTP2 connections. And then there's Epsilon GC. That's the garbage collector, probably the coolest garbage collector ever, because it does really nothing the entire time. And when you ask it for more memory, it just fails. That's interesting. Garbage collector is basically the smallest amount of work you can do, which is why it's called Epsilon. Why would such a garbage collector, what would that be useful for? Why would that be in the JDK? Well, if you're writing your own garbage collector, you want to compare it against something, you want to measure your overhead, then it's really kind of hard to measure your overhead if all the other garbage collectors have their own overhead. That's kind of complicated. You need actually one garbage collector without overhead that you can compare it to. That would make those numbers much more reliable. There you go. Epsilon GC does exactly that. It has a minimum overhead required, and so you can work on your GC against that. That's not even the only use case. Some projects or some applications are run for just a short period of time, maybe just a day, or maybe even a week, without a single garbage collection run. So these are usually tools that are very low latency, so they can't stand the pauses that a GC might impose on them. So they manage to run the entire program without a single collection. And then it's nice to have a GC that doesn't incur any overhead. But obviously, these are both fringe use cases. So we could look now at launching a single source file. Once again, we're going to skip that. But this is about this feature here, right? How this works, what you can do with it. Just a small spoiler, you have shebang support. So that means if you're on Linux, you can throw in this line into the first line of the source file, and then you can execute your stuff like this, your script. So if you're Linux and on Java 11, you can write your own scripts in Java, which is really great, except it takes a second to launch the VM. So it always takes kind of a while. Well, maybe it's not exactly a second, but it takes a visible time while you're waiting on the blinking cursor on the command line for this to finish. So now, right, isn't that awesome? You might at this point feel like you're being spoon-fed new Java version. So 10, 11, both of them are pretty small, nothing really too juicy to look forward to. Java 11 in particular, no language change, no monumental dev-facing feature. But this is not a bad thing. This is actually good. It means that the amount of new stuff in 10, 11, 12, 13 is of course way smaller than the amount of new stuff in 8 and 9, because it's just 6 months. Once again, we're going to discuss that in a little bit more detail later, but this will become common, and I think that's okay, that there will be Java releases where you don't feel like this is revolutionizing your work. It will instead be a slow evolution over time to bring about the same amount of change. And that concludes the parts on versions and features. So I invite you to ask some questions. I'll drink water and give you a couple of minutes, or a couple of seconds rather.
All right, we have one question actually. It's about the var. So the person asked, var is only in local variables. Is it?
Yes, that's absolutely true. The reason for that is that while the compiler can, of course, infer types from all over the place, it could infer types across method calls and all that, that would make it hard for the developer to track what type you will find where. So var was not made to mask the type information. var was created under the assumption that the type information is obvious from the right-hand side. So it should always be only used very locally. And that's the reason why you cannot have var fields, you cannot have var parameters, your return type cannot be var. You can only use var for local variables and then in loops and in try, because all of these variables are very local.
We have one more questions. Well, it's maybe not related to this section, but I'll ask you anyway. So what he is asked is, what is the difference between Oracle JDK and OpenJDK?
That's a great question, and we're going to come up to that in a couple of minutes. Yeah. That's exactly what we're going to be talking about.
All right.
Thumbs to whoever asked that. Great. First, we're going to look at the release plan, the new one, the old one and the new one, and then we're going to go to OpenJDK and the other ones. Oracle
okay, sure.
So the old release cadence had kind of like a weird conflicting idea. The first one was releases are driven by flagship features. Java 8 will be the Lambda release, and Java 9 will be the module system release. So we bind these releases more or less to flagship features. But also we kind of want to have a release every other year. And these are obviously conflicting situations where the 2 years are up, but the project isn't done yet, or the feature isn't done yet. So the reality was that it really didn't work. Java 7 took 5 years, although I think nominally the 2-year release cycle was announced or was aspired to publicly only immediately after Java 7 came out. But then Java 8 took 3 years, Java 9 took 3.5 years. So this obviously didn't work out even after it was published as an aspiration for the development team or for Oracle as a whole. And the reason for that is that when a feature is almost done, it's really hard to bump it 2 years into the future. At best, I mean, look at these times. It was never 2 years. So realistically, you're looking at 3 years delay, but it's almost done. And so you make them move the date a couple of months more. And then that's exactly what developers do all over the world. I can't count how many often I said, like, I'm almost done. Just like give me 2 more days. So the idea was like usually the decision was made. Well, then we just delay the release a little longer, and then we'll catch the. Then we put it in 2 months' time, and then it was 4 months, and then 1.5 years, and there you go. So the downside of this is that features that are ready and implemented are just sitting there and can't help anyone. So particularly Java 9 was interesting in this regard because there were many people who said they didn't really wait for the module system. They didn't really like the module system. They didn't really want to do anything with that. I obviously disagree with that opinion, but the point is that people said, like, look, I don't want to use the module system, and that's fair enough. But they still had to wait for the Java 9 release for ages, even though other stuff was already in there that was ready. And that's kind of frustrating, right? You're waiting for something that you want to have, and it's there, it's ready, but you can't use it because you're waiting for something else. You're waiting for Jigsaw to be done, for example. This also increases the reaction time. Having a release only every 3 years makes it really hard to do something like implement this feature now, but you will have one release time to give us feedback and we'll change it. One release 3 years in the future, that can hardly ever happen. It puts the pressure on projects to be done on time, and that makes everybody grumpy. The developers, the community, I'm sure people in between that pipeline, like managers and stuff, I'm sure they're also not very happy. So everybody really loses in this situation. So enter the new world. If it hurts, do it more often. I think it was from Martin Fowler, right, in continuous integration. The idea was, why not have a fixed release cadence? Fixed every 2 years, bumping a feature 2 years into the future, nobody wants to do that. Fixed every 1 year, still kind of like having to bump a feature a year. Okay, 6 months. That's easy. I can easily bump a feature 6 months into the future. I'm sure this was not the only reason why the decision was made, but this surely played a role. To have a release cadence, it's really easy to just push a feature into the future if it's not done yet. And whatever is done by the time that this feature gets shipped, that this release gets shipped, all of those features are going to be shipped, and everything else will not be in there. So that's really a straightforward model, actually. It's important to understand that all of these are major releases. Java 9 and Java 10 are not alpha and beta versions of Java 11. These are not in any way beta versions or minor releases or anything else. The only difference between 9, 10 on the one hand and 11 on the other hand is that one of them is marked as LTS. And we're going to look at those impact of what that means, but there's no technical difference other than that. Well, that's not a technical difference. There is no other difference. There's no technical difference at all. This is the only one. Okay, so how does it work? How is this development process implemented? It's actually very similar to what regular teams would do, although we usually use branches, and I'm going to talk about branches here as well, but these are forked Mercurial repositories. So this is it's one level more complicated than this, but this is totally right, it's pretty accurate to how it works conceptually. So features are basically developed in a branch. We have long-living feature branches, and when the thing is finished or like really nearly finished, then it gets merged into master. And then 3 months before release, 3 months before the Java 11 release in March, for example, in the middle of, that was September. So in the middle of June at some point, June or July, a release branch for Java 11 was cut. And everything that was in master by that time was in the release branch, and everything else that was merged into master in the future, well, that's not in the release branch. What can still happen in the release branch are, of course, bug fixes. So these features get stabilized and improved over the final 3 months. And then in the end, you get your release from that release branch. That means that completed features get out way earlier, which is pretty good. So the longest time you have to wait would be 9 months. If your feature is done like 2 weeks after the deadline for Java 12, it's going to be 9 months until Java 13 is released. So that's the longest possible time you have there. That's pretty good. It's very easy to, or it's easier to incubate features, which is something we're going to see in Java 12 forward. We're going to have preview language features. So there can be a language feature that is not yet finalized. It's basically done, but there's still the JDK team still waiting for feedback before they finalize it. There's also things since Java 9, which is called something module, experimental module. Damn, now I forgot the name. I think this shows up later in the slides. So some kind of module for experimental API that you can that is already deployed with the JDK. You can start using it if you use special command line flags, so you can gather experience with an API and give feedback, but you cannot really use it in production well yet because you have to add tons of command line flags and nobody wants to do that. So since Java 9, you can test APIs. The HTTP2 API that I said was released in 11 was actually present the first time in 9. Then was overhauled a lot for 10, and then was refined for 11. And then 11 only wasn't stabilized and would officially support it. So this makes it easier to react to changes in the ecosystem if you can start giving people something that you think works, but then having the chance to refine it over a version or two. The question is, doesn't this make life complicated for everyone? Java will change much too fast. We'll have to constantly migrate, which is very expensive. The test matrix, so this, let's say you're developing a library, now I have to test my library against 10 Java versions instead of 3. And in the end, the ecosystem will fragment and we're all going to end up in a very bad place. I don't think these are realistic. And I want to give you my opinion on this. So I'm going to say, don't panic. There's no reason to think all of these horrible nightmares will come true. So let's talk about the first thing, that the change is going to be too fast. Mark Reinold himself said very succinctly, the rate of innovation doesn't change. The rate of innovation delivery increases. That means over the same amount of time, about the same amount of developers are working on roughly similar features. So there's no big change in how fast they're going to get work done, right? That means that the amount of change you're going to see over, let's say, 3 years, which on average was 1 Java version in the past and is now 6 Java versions, then that amount of change is similar or maybe even the same. Over the 6-month release cadence, you just got the stuff sooner. You didn't have to wait 3 years for everything, but nothing individually got completed faster than the old model. My personal opinion is that I think speed may pick up a little. Project Amber is implementing a couple of low-hanging fruits, like var, for example, that are, while of course it's so complicated to work on compiler and JVM, are much simpler compared to Lambda module system and Valhalla, for example. And my general impression is that Oracle is focused a little bit more on Java core. So Java E, for example, is not something I have to invest time in anymore. And Swing and AWT and JavaFX are not exactly don't exactly see a strong backing by Oracle. So it kind of feels like they're focusing on Java core, on the language, on the JVM that supports it. And I think so we'll also see a couple of, that's what also why speed might pick up a little. Once again, that was just my personal opinion. No idea whether that turns out that way. So by and large, evolution will not be faster, will just be steadier. And Java 11 is a great example for that because Java 11 had really no awesome features where you looked at it, it's like, wow, I have to do this. And that's, as I said, that's okay. That's an indication that evolution will be just steadier, not faster. Then about those expensive migrations. If you migrate to Java 9, then you know that that's tough. If you're now thinking about, wow, we have to do this every 6 months now. It took us 6 months to do the migration. Now we have to do it every, like basically continuously. I really don't think so. So while yes, I think work on updates will pick up a little because you have a way higher incentive to always be pretty up to date, even not entirely up to date, but at least not running 5-year-old unsupported releases of, let's say, like running Spring 2 or 3 or something. The incentive not to do that gets higher, but I think that's good actually. Java 10 and Java 11 were pretty easy, the migrations. So even though you have a high incentive to stay up to date, it's not like you have to invest the amount of work that you invest into Java 9 every 6 months now. And Oracle is still committed to backwards compatibility, although there's a balance between compatibility and evolution of the language. And that balance shifted a little bit. So it was Java was very, very conservative, was very much in the corner of compatibility above everything else. even if that hinders evolution. And we're still pretty far in that corner, right? We're just moving a little bit out of it, a little bit more towards evolution. So for example, one indicator of that is that the deprecated annotations in Java 9 got a new for removal attribute. And that means that stuff will actually get removed. And this is how you learn about it. Methods or classes or even entire packages might pop up with this annotation. It's deprecated, but it's not just deprecated in the old Java sense of I get squiggly lines or compiler warnings and never care about those. But if it's for removal true, then these things are going to be gone in the release or two. So that can happen, which almost never happened or even never happened before Java 9. I'm not entirely sure. Well, all the promises you got that stuff is going to be supported for one major release, that promise just had its lifetime cut into a sixth, right? Because it used to be 36 months until the next major release. Now just 6 months. So all of these promises, you can still uphold them, but now they just apply 30 months less. Every new Java version that comes out has a new bytecode level. And while that seems very technical, and why would that matter in this discussion? The reason is that bytecode manipulation tools that work on the bytecode, and they don't work on newer levels than they're programmed for, of course. So that means everything that operates on bytecode will have to get updated very frequently with this release model. Now you might be saying like, I'm not doing that. I don't work with bytecode, and that's most likely correct. I don't do that either, but the tools we use do. So ASM, for example, which is in the Maven compiler plugin, does that. If you're using stuff like Mockito, for example, everything that depends on ByteBuddy, all of these kind of tools do operate on the bytecode, and they will have to be updated very frequently, basically every 6 months as well. So this can actually lead to a little bit more expensive migrations. And then the last thing was incubate. Oh yes, haha, incubating modules. That was the name. So incubator modules. Sorry, incubator modules. That was the ones I talked about earlier, which contain API that is not yet done, but you can already play with. And there are guardrails in place against developing a library against that. So if what you don't want to have is somebody who develops a library to develop that against an incubating language feature or an incubating API, and then people start using that because they don't know what it's doing, and then the API gets changed to the next release, and then the library breaks down, and people start complaining at the JDK team that how could they break the API. So to avoid all of that, the idea is that it's really tough to write a library against these incubating features, because you have to use command line flags during compile time and at runtime. So basically telling your users, if you want to use my library, apply these 3 strange looking command line flags and don't ask me why they're there. So that actually gives users an incentive to really second guess you at that point. Like, okay, you're using all these unsupported APIs. I should not be depending on this. So that's why it's really hard to actually depend accidentally on incubating language feature or incubating API. But if you really try, or if a developer on your team, if they really try, then they can get you there. Yeah. So, but I think that's a very slim chance. So all in all, even though in each of these points means a slight increase in migration costs and migration risk, I don't think that the impact is very big overall. So I don't think that migrations will become much more complicated and much more work than in the past. What can you do to keep migration pain small? You can, of course, stick to supported APIs, which should be the norm, but sometimes somebody starts using something internal. Stick to standardized behavior. What I mean by that is that don't accidentally depend on implementation details. That's sometimes hard to notice when you start doing that. But you know that feeling when you're writing a class or writing a piece of code and you're like, okay, how does the JDK behave here? Let me figure that out. Let me make a couple of tests. Okay, now I understand how the API behaves. And I'm gonna write my code accordingly. Then that's normal, right? You do that every day. At least I do. But sometimes you realize, oh, the way that I understand this API now, that impacts not just the code, but like the entire subsystem I'm writing right now. If this doesn't work that way, but that way, then I have to rewrite the entire code. If that is the case, then take a very close look at what behavior you're depending on is actually promised or is just an implementation detail. So an example for that would be to rely on the iteration order in which the reflection API returns some methods. That, for example, is an implementation detail, but you can start depending on that accidentally. So if you make one of these decisions where you feel how the JDK behaves here has a high impact on my code, then make sure that you actually depend on standardized behavior by reading the Java doc. If it's a language feature, reading the JLS to make sure you get it right. And generally, it helps to stick to well-maintained projects because they will update sooner to new Java versions. And if you keep dependencies and tools up to date, then you will have much less problems, much fewer problems. You can just make the most recent updates every time in that ideal world, even though that's not easy to get there. It's not easy to stay there either. And finally, consider using JLink. With JLink, you have the ability to create an image which contains the JDK code that you need, the dependencies that you need, and your code. So basically shipping a binary image to your customer specific to that operating system, and they can just launch that thing, and the entire JDK is in there. So that way you can ship them JDK 9 if you want for the next 10 years, and so you don't have to make that update. That has obvious security and performance problems relying on that approach. So I'm not saying you should do it that way, but you could do it that way. So you have to consider how to best fit JLink into your update strategy. About the exploring test matrix, yes, this one is true actually. If you're developing a library or tool or whatever, and you want to guarantee, say, compatibility across 10 years of Java versions, then as you could have picked 7, 8, and 9, and no, sorry, 6, 7, 8, exactly. You could have picked those 3 Java versions, and you would have covered almost 10 years. And if you want to do that now, that means in the future you may have up to 20 versions to support. That's ridiculous, of course. But so yes, testing test matrix might explode if you actually have to support different Java versions. And that also means that the developers have to switch between different Java versions occasionally. On just during development, you might realize, oh, this bug only occurs on Java 9. Let me quickly switch to Java 9. All of that is possible, but some of the things I think could have improved usability. But most important here is most tools already can do this. We just have to learn how, and we just have to make sure that we automate as much as possible. If it takes you 2 lines in the configuration file or just a mouse click to launch a new build server, which runs your entire build on a different Java version, then this is really easy. If on the other hand, you have to put some engineer aside for like a week to set up a new build, then this becomes very painful. So automation really helps here. Then finally, would this be like Python 2.3 where the ecosystem will fragment into different pieces? And no, there's just not a realistic chance that it's going to happen. This slide is I took from Mark Reinhold, but there are also, works fine on JDK 9. Works like heaven on JDK 11, and I forgot the 10 part. Never mind. So the joke here is all of these things, of course, work on 9, 10, and 11. And so don't worry, much of the stuff that you're using is already compatible. And there might even be, and there are definitely things that are not on the list here that also work on Java 9. So don't worry, just try it out. You have a good chance of making it work. I don't think there's a high risk of this causing major problems in the ecosystem. Across the entire ecosystem, there might be individual projects that suffer more than others, of course. So a summary of the advice that I gave you throughout this. In general, I think it's the best decision that you can make as a development team is ideally you sit down with your management and your customers, and then the project decides on their own what the suitable update cadence would be. Do we go every 6 months release? Do we go with all the long-term support releases? Do we try to find somebody else who supports the version in between so we can switch every 18 months? This is a discussion to be had by as many people as possible, I personally think, and then decide together. If you can, you should build on each release, just to make, even if you're deploying your code to your own cloud, for example, you can pick the Java version. Maybe you're still running on 8. Never mind, still build against 11 at least. When you're on 11, build against 12 or 13, whatever's out, to make sure that you catch problems early, that you can react early. If you're using early access builds, you can even give feedback. So Java 12 early access builds have been out since, I think, July or August. 12, right? Not 11. So since August, you could download JDK 12 and play around with it. As I said, only rely on standardized behavior. Then there are deprecation warnings that should really heed. As I said, deprecation warnings can now have lead to removal of an API. So if you don't compile against Java 11, say, and see those warnings, you can also use JDepreScan. You use JDepreScan, for example, from the JDK 12 EA download and run it over your bytecode. And then it will tell you which APIs you're using. And I think it points those out that are marked for removal. And you get a nice little report on the command line there that you can then put into action. And so this should definitely be the absolute minimum that you would do to stay somewhat up to date, to make sure you understand what versions are going to be released and removed in the future, and whether that impacts your code or not. As I said, keep dependencies and tools up to date, but also be aware of what's coming up. I think it's a lot of fun to see what's coming because it's new, but also because it gives you better understanding of how the ecosystem works, how the technology works, and um, gives you a chance to react to changes early and give feedback that's then taken into account. In the past, it was good to focus on features, sorry, on versions, right? So you thought about Java 8 about a year before it came out, so you just Googled Java 8 and you found a lot of good sources. I don't think that will work in the future. I think in the future it will be more practical to focus on the individual projects and Java enhancement proposals that back these projects that are being developed, so you can have a better understanding of what's coming up that way. Because nobody knows what's going to be in Java 14. At this point, it's just guessing, and chances are very high that the feature you're guessing would be in 14 could be in 13 or 15 instead. So there's really no good way now to write content for Java 14, which means by the time Java 14 is out, there's not really that much content focused on that. There will be much more content focusing on what happens in Project Valhalla, what happens in Project Ember. At least that's what I hope. And so I would recommend to look out for that. So let's have a look at what's coming. But before we get there, now we're going to talk about long-term support, about different JDK versions, and about all of that. Do we have questions, though?
We have actually many questions, but I guess we can take them later.
If you want to, sure.
Yeah.
Okay, let's continue with long-term support then.
Okay, sure.
So the underlying question is, what do you want to do, you or your project? Do you want to update every 6 months? Then none of what I'm going to say now applies to you. If you don't want to update every 6 months for whatever reason, and there are a couple of good ones, then this might interest you. Let's first talk about Oracle JDK and OpenJDK. So OpenJDK and Oracle JDK in the past, and Sun JDK before that, built mostly on the same code base, but it's not entirely. It used to be not entirely the same code base. But by and large, they were identical. You could get a JDK 8 from Oracle, or you could get the OpenJDK 8, and they would support, of course, all the same APIs and all the same language features and all that. But Sun and Oracle's JDK was conceived to be have more features, be more stable, more performant. Some of those things are true. That for more features, for example, that's the case. There's some things like how to analyze the JVM's performance, for example, a flight recorder that used to be only available as a commercial feature in Oracle JDK. Then about more stable and more performant, I can't really attest to that. But I know that people perceived it that way and thought Oracle JDK was basically the good one in OpenJDK, that will somehow be somewhat inferior. And maybe that used to be the case in the past, but both Oracle JDK and the OpenJDK community worked hard on minimizing that difference. And they're already quite compatible in Java 8. And then 9, 10, and 11 introduced a couple of changes that now by 11, Oracle JDK and OpenJDK are identical. Small asterisk there. If you click there, you can follow that link. You can read about the very, very few differences that remain. But I think they're not important for like 99% of the projects. So by now, Oracle JDK and OpenJDK are technically identical. And if you think about JDK 8 support, then I think Red Hat is at the moment picking up the JDK 8 update project from Oracle. So Oracle used to provide free updates for Java 11. They stopped doing that in January. As far as I understand, Red Hat will pick it up from there and will start releasing updates to the OpenJDK 8 project, and then release updates of OpenJDK 8. If that's important to you, then you should look that up. But that's one way that you might get support without updating at all, and without paying, by the way, because OpenJDK, of course, is the open and properly free version. So the difference that remains between Oracle JDK and OpenJDK is the license and the support model behind that. So Oracle ships OpenJDK builds at jdk.java.net. And that one is licensed under GPL plus ClassPass exception. Basically the same JDK plus some branding. That's Oracle JDK. That one is fully commercial. So from 11 on already, you cannot use it in production for free anymore. You can use it for development, for testing for free. But if you have Oracle JDK 11 running in production, then you would need a license for that. Since that would mean you're buying support from Oracle, which might be the best decision for your project. If you're doing that, then you would use Oracle JDK, which is identical to OpenJDK. But most people, out of habit, don't do that. The Oracle JDK will come to show you links later where the prices are hidden. it's comparatively cheap to buy Oracle JDK support. But that's not my point. My point is, if you prefer to use a free version, free like in beer and in freedom, then OpenJDK will be the new normal. OpenJDK will be the version that I think most of the development community will start using on a daily basis. So my assumption is that over time, the ecosystem will switch to OpenJDK is what I always pick, unless there's a reason not to. Unless I learn that I need support, or I'm running on an old version, or I have a customer who needs who have to show that I have to support. There are various reasons why you don't want to use OpenJDK, but I think that OpenJDK will become the new default for every project. So what does it mean then when Oracle says it supports something? Oracle supports free updates for the current OpenJDK version. That means what they publish at jdk.java.net, those versions that are published there, they will get the most current OpenJDK version will get updates for 6 months, including Java 11. Java 11 just under this regime only gets regime sounds maniacal. I'm just saying, let's under by these following this bullet, just gets updates for 6 months for free. But for selected versions, for Java 11, 17, 23, you can buy commercial support from Oracle for Oracle JDK. That's called the JavaSE subscription, and the prices are linked there. And I think it's $2 for a desktop, and I forgot the price for a server or server core. I don't know competitive cloud prices for some similar support prices for similar kind of services. But to me, the prices don't feel exaggerated. But that means there is no free long-term support for Oracle. So when Oracle says there is long-term support for Java 11 and 17, then that's true, but only if you pay Oracle for that support. So that used to be a little bit shocking. I think by now most people know that. But it used to be shocking to me to figure out how this is going to work, because I just misunderstood what Oracle said earlier. I'm not entirely sure whether that was an accident that I misunderstood that, but yeah. So how does Oracle handle these bugs and security fixes? I'm walking you through this so you understand what it means someone supports your JDK version and how that support comes to be, what that actually means besides being able to call someone. So let's walk through how Oracle handles bugs or security fixes. There's an OpenJDK repository, and Oracle will, on master, develop, usually assuming it's a bug that applies to all, including the current version, then there will be a bug or security fix or whatever, will be developed on the master branch, on the main OpenJDK repository. And then Oracle will take that patch and merge it into the current versions branch. So at the moment, that would be Java 11. If a problem occurs now, Oracle would fix it on master, will then merge this into the Java 11 branch. And then they will take an internal repository, and then they will also merge that change to the current LTS version. That means, from a technical point of view, what long-term support really means is someone takes that patch from OpenJDK master, because there it's visible to everybody, and applies it to the old versions release branch. For example, to the Java 8 release branch or to Java 11 release branch. That's what long-term support means on a technical level. You can get commercial long-term support from Oracle, IBM, Red Hat, Azure. Although maybe I should not have IBM and Red Hat as different companies anyway. You will see, might be, I'm pretty sure, oh yeah, of course, Amazon, but that's not commercial actually. So there might be other companies as well. You can pay them, you get support depending on what they offer. I think Azure, for example, offers support for more than just every 6 year versions. So you can get like, I think, Java 12, 15. Yes?
I have a question actually about that. So since the IBM and Red Hat are getting along, I mean, actually IBM acquired the Red Hat, so they have two JDK right now. Is there any? I mean, I don't know, but I'm assuming they will not keep both JDK alive. What do you think? Do you have any opinion on that?
I don't know the companies very well, so I shouldn't speak to that. Just from a purely technical point of view, once again, I'm almost clueless. I have no idea how widely IBM is used and what IBM offers in its, the IBM JDK, and what exactly it offers beyond the regular JDK. So I wouldn't know whether it would make sense to combine these projects, but maybe these projects have different purposes. So maybe it makes sense to keep them separate. I really don't know.
Okay, thank you.
Sure. Okay, I mentioned all these. Now, what about free long-term support? We're kind of spoiled in the Java community. We got we get a lot for free. We used to get a lot for free. Now we may have to put in a little bit more work because by what I just described, there is no long-term support for free, right? The only long-term support you get is for 6 months. Sorry, the only support you get is for 6 months, hardly long-term, and beyond that you have to pay someone. But now it looks like there's like this is going to work out. So there are discussions on the mailing list that and maybe this I'm out of date for like 4 weeks, so maybe already things changed here. But the current state information that I have is that Red Hat will most likely offer to take up the OpenJDK 11 update project and start merging these patches basically there. So basically, this, as I said, is mostly about taking existing fixes and applying it to that release branch. But that might sound trivial, but it can absolutely be complicated, right? If you consider major changes that are upcoming, let's say Valhalla enters the JVM in, let's just say Java 14. I'm just making up that number, right? And having a fix from 15 and apply that to JDK 11, that could be serious work, like serious technical work. So this will by no means be a trivial task, and I'm looking forward to whether this works out. And so this is how the versions will be supported. 11, 17, 23, most likely there will be Red Hat or other companies stepping up and supporting these versions. They're basically putting the code into the OpenJDK repository, and then they're building those for their own customer. But we also found our own build farm, Adopt OpenJDK, is a community project that sprung up, I think, largely around the London Java user group. I'm not sure though. And they build and ship that code, I think, on a nightly basis. So that's the aim, at least, to take the OpenJDK code from all different branches, master and development branches, and release branches, and build JDKs for each of these and publish them at Adopt OpenJDK. Andrew Haley from Red Hat wrote about this. Let me assure you of one thing, whether by Oracle or Red Hat or someone else, JDK LTS releases, OpenJDK LTS releases will continue to be supported. We all have a lot invested in Java, and we won't let it fail. So yay! This looks pretty good. Looks like we're going to get free support, which is not only good from a monetary perspective, of course, but largely I like the idea that there's a proper free version of Java UPL license that is always up to date and can always be used in various versions, including those that are long-term supported. A small addendum that I didn't yet put into the slides. Amazon, I hope I put that right. Pareto.
Yes, Pareto.
Yeah, that's Amazon's OpenJDK build that they are supporting. They're supporting Java 8 for years to come. They want to start supporting Java 9, I think, 11. They want to start supporting Java 11 in January, and then also for like 4 years or something. So this looks very promising, like just another big player that wants to support, and also that offers support for Java. It looks like Pareto will be, or it is definitely free in the sense of GPL and of monetary reasons. So you can at least use Amazon's OpenJDK for free in your own projects if you want to. You can collect some questions. I'll be back in a second because my daughter just came in and had a question.
All right. So guys, if you have any questions, it's the time. You can write on the chat. So ask question as much as you have. We'll try to answer on time. We're almost 1 hour, so 5 minutes to go, but I'm sure we'll have some time to catch a few questions. So it's time. Ask few questions.
I'm back.
Oh, okay, great. Okay, so let's take some questions. Basically, I'm sure a few of them already answered, but I'm going to ask you anyway. So one is the difference between Oracle JDK and OpenJDK, and that is already covered, I think. Then there is another one, which is Corito and OpenJDK. What he asked is, which one do you prefer? The Amazon Corito or the Adopt OpenJDK?
Well, I think just by habit, I would prefer Adopt OpenJDK because it's a free community project. But that's once again, I think there will be no technical reason, no technical basis for that preference. At least not if Adopt OpenJDK works as well as they hoped it will, right? if they can't get updates regularly because I don't know the build pipeline causes troubles and they don't have the manual or monetary resources to fix that. I'm not saying that's the case. I'm just saying if that were to happen, then maybe not. But otherwise, for me, OpenJDK will be adopt OpenJDK would be the default, I guess, to download OpenJDK builds.
So there is another question. It's sort of from the Android community. Right now we are in fact stuck with Java 8 in the Android community, and people are sort of thinking otherwise. Should we go to Kotlin or should we stick with Java? So, do you have any idea on this or any opinion, perhaps?
I don't know the Android ecosystem well, so I have no idea how exactly this impacts that. I don't know how this could work out between Google and Oracle and getting, for example, whether and when JDK 11 will be available on Android, or at least the API and the language features. I have no idea. Regarding Kotlin, on the other hand, uh, I just started using it on a new project, and I do enjoy it. And there's a big company behind that will make sure that Kotlin will not die, at least not without a fight. So I think it's fairly safe to rely on it, even though it's still pretty small. It feels like there's enough support to rely on it and use it in production for your next project maybe. And I like using it so far. But once again, I didn't use it enough to make an open recommendation for it. But if you have a way to try something out for an, I don't know, for like a hackathon or for a small customer project where the company might be able to chip in a couple of extra hours to fix something should go wrong, then I would recommend to give it a try and to figure out how well it works for you. Because as far as I see, it's very promising. I like using Kotlin.
All right. So there is another question. It's about security. So what he asked is, as OpenJDK is open sourced, and how security is compared to Oracle JDK. Although we know that they are binary compatible.
Yeah, but they're not only binary compatible. Binary compatible leaves a wide range of changes how things will look internally. So binary compatible is when it comes to how similar are different JDK releases, then binary compatibility is extremely weak. No, this is the same code. Literally, this is it's a different build server that picks the code from the same repository, from the literal same Mercurial address. So this is the same code. You will find fixes of one in the other. What could happen if you're on a long, if you're using a version that was released not most recently, but let's say a couple of years ago, you still say in 3 years you're still using Java 11, or in 2 years you're still using Java 11, then what I said earlier applies. Oracle JDK will have that fix and it will be in master, but it may take some time to show up in the OpenJDK release branch. So there is a chance that you will see some of these fixes a little earlier, but at least Oracle does not release its minor updates based on need, but also following a fixed timetable. So 11.01 comes out a month after 11. 11.02 comes out, I think, 2 or 3 months later. And all the security fixes go into these releases. And there's no, so this can be aligned, right? So OpenJDK and Oracle JDK could align these releases and these fixes so that both have exactly the same security fixes. But aside from maybe a delay of a matter of weeks, maybe before a fix that is available in Oracle JDK 11 also makes it to OpenJDK 11. Apart from that, I don't think there will be any security implications on which JDK you use.
All right. So we have actually another questions. I think it's important. As we Java developer, we have a tendency of getting a lot of things, similar things, and too many things, and then we spend time which one to prefer. So we have actually too many JDKs, and then is it not complicated? I mean, Java have too many JDKs. Which one to pick and which one to not to pick?
Um, I mean, this is not. It's not really like there are more JDKs in the past. It's like maybe from Amazon's, but all the other JDKs existed in the past as well, right? I mean, you had OpenJDK, which you could build yourself. You had Ice-T. There are all kinds of JDKs for smaller appliances. You had Oracle's JDK, of course. You had IBM's JDK and Azul's. So it's not like this adds another JDK into the mix. what this does is rearranges the hierarchy, and I think in a great way by putting OpenJDK at the top, which is the source of truth, though some of its derivatives might have, in an old version, might see a specific security fix earlier maybe. That from that aside, all this code comes from the master branch or the master repository from the OpenJDK. And so I think that these things will rather more converge rather than diverge further. So I would not worry in that regard. We managed it this far. I think we'll manage it in the future.
All right. So I don't think we have any more questions. Okay.
Okay. So we're scheduled for an hour. We can go over, no problem. But you got to tell me when I'm taking too much time, right?
It's all right. No problem. Go ahead.
Okay, cool. So let's look at. Oh, sorry. Yes, we saw this slide earlier. Don't focus on versions. Let's look at projects and Java enhancement proposals, and let's see how these are developed. And I want to have a look at what's coming. Disclaimer, this is the only new thing on this slide. Last line. I'm going to show you syntax, and that syntax is mostly made up, partly even by me. So that doesn't mean that the syntax will look like that. I just try to put it in a way that makes the most sense on these slides. So don't focus on the specific syntax, focus on what the underlying meaning is. There are many great projects. I selected 5 here, although yeah, but I only talk about the first 3: Amber, Valhalla, and Loom. Metropolis and Panama, I'm not really so qualified to speak of. So let's focus on the first 3. Let's start with Project Amber. Project Amber focuses on smaller, productivity-oriented Java language features. It's led by Brian Getz, who also implemented Lambda expressions and Stream API. Well, of course, not on his own, of course, but he led that project as well. Once again, there are links here. There are already links to several talks on the topic, which are highly interesting, all by Brian Getz, I think. I recommend having a look at them. The project was launched in March 2017. It already delivered var in September 2018. So that was a short turnaround time, which is kind of what we're getting used to with Project Amber, because really focusing on smaller things that are fairly quick to implement. So the motivation here is that compared to other languages, Java can sometimes feel cumbersome and lacking expressiveness. We have to have a lot of boilerplate to make things work. And Amber generally wants to improve that situation. A couple different endeavors. Let's have a look. Oh, I really didn't update this slide because the last slide is not true anymore. But let's focus on that in a minute. Let's look at the first part here. This is a raw string literal. That means everything behind between these backticks, everything in between is taken literally as it is. You will see that there's no escaping at all of quotation marks, of tags. You don't have to escape anything. There are new lines behind each tag here. There's a new line, of course. It will also be in the final string. So you can type a string into the source file, and it will be taken raw as is, as the final string. So that's pretty cool. Multi-line strings and no escaping of special characters. And now it says preview in Java 12. Which was just, I think a couple of days ago, it was pushed back to 13. So it was already merged, and at least was scheduled to be merged. And now the assumption is no, this. So I think Brian Getz put it that he said, when a preview feature, even if it's just a preview, we're only going to publish it as a preview feature when we are sure that unless a lot of new information comes up, no changes are required. So the assumption is basically this feature is done. We're not giving you something half-baked. It's done, but we still want to give it half a year of feedback. And they say at this point in time, they're not sure whether this implementation of raw string fields fulfill their criterion to be really, that they are sure that's not going to get changed. So it's not a preview in 12 anymore. Switch expressions are, though. Let's have a look at this. Day of the week, day is some day of the week. Let's assume there are 7. What I'm doing here is looks like a normal switch kind, right? I switch over something and then wait, what are these arrows? So interesting thing is that this entire switch, now it gets a value. That means it's an expression. It can be evaluated to a value. If day, say, is Monday, then we'll land in the first branch, and the result of this entire thing will be 6. So num letters will be 6. And if it's Wednesday, then the last case will work, and then will be 9. So this means you can switch. You can use switch more elegantly than in the past. If you want to assign the value of switch to a variable, you can now do that this way instead of having to return the value from a method or even assign and break. In this, if you write it this way, no more breaks are necessary, which is really great. I hate break with a passion because they just blow up so much of the code. And the compiler can check exhaustiveness. So in this scenario here, assuming we have 7 days of the weeks, they're all in here. You don't need to put a default branch. The compiler understands that there are no more cases to be had, so it's happy without a default branch. I made a video about this, which you're highly invited to watch later, where I go into all kinds of details on this. Now let's instead continue and build something on top of switch expressions, which is pattern matching. So what pattern matching means is it uses the same idea that a switch is an expression and you can assign a value and that you have this kind of lambda syntax. All that is the same. Different is what happens on these conditions here with case. Before you could only really case against strings and couple number value, numeric types, and enums, of course. Now you can, with pattern matching, you can check more complicated things. Here, for example, we check the type. Is value of type integer? And if it is of type integer, then declare new variable e that contains that reference as an integer. So back here on I, you can use integers API. For example, down here, if it's a string, then you use it as s here, and this s, for example, will have a method length, because string has a method length. So what this thing really does, it checks whether this the values of this type, and if it is, it creates a new variable of that type, so you can use it properly back here without having to cast it. So this is pattern matching in the sense that this in the front here, it's a pattern, and this pattern is, are you of that type? That pattern was, are you an instance? Are you this instance? This one is, are you of that type? You can make up more complicated stuff. We're switching over some kind of node here. Is that node an int node which was created with an I? Wow, was it a negation node that was created with another node? So what we're basically doing here, we're deconstructing this object. So an int node, apparently node is an interface, and int node sounds like an implementation of it. What this basically covers is a small computational tree where you have a node that can either be a number, or it can be the addition of two numbers, or two other nodes, sorry, or it can be negation of a node. I think it's fairly straightforward, but the interesting bit is this taking apart here. So we can say the node that you have, is it actually a negation node that was created with another node? If so, I want to use that node back here. So you can see this is way more complex and powerful than just matching against enum values, strings, or even types. And this could actually make a lot of implementation of the visitor pattern unnecessary, which even though I know the visitor pattern definitely has its uses, but I'm unfortunately occasionally working in a code base where it has a lot of uses, and most of them are actually valid, but you still see visitor a lot, and it's just complicated to debug and to analyze, I think. Anyway, that's just my personal gripe with a visitor pattern, which we can reduce the use case for with this way. So how does this work? Why can I just split up this node here? Why can I know that it's a negation node that was created with another node that looks like constructor call? How can I even know how this is created? This is where records enter the picture. A record is something like this. Public record instead of public class, maybe. Who knows how this will turn out, the syntax. Range, and the range has a low and a high value. And that's all I need to write. That's all. Oh, without the comment, of course, because that's what the compiler does for me. It generates a constructor. A deconstructor. Because what we've seen up here, that's a deconstructor. It matches the constructor. It basically tells the object how to take it back apart. And this is, if you write it like this, then the compiler knows, oh, you need a compiler, so you need a constructor. Sorry, I'm blank there. You need a constructor that takes two ints, but I'm also going to provide you with a deconstructor that, given you have a range, you can get the two ints back out. So it generates all of this for me. And that means that I need way less boilerplate for these plain data carriers. Then it gives me equals and hash code. I don't need that code. I can't make mistakes there. But most importantly, it makes Java more expressive, because what you can really do is you can tell the compiler, the JVM, and your colleagues, look, this is a record. This is just a data holder. There is nothing big, nothing's encapsulated here. It just carries a lot around with it some data. And we're going to see now how that plays out. The idea here is the API for a record models the state, the whole state, and nothing but the state. So you don't encapsulate anything. That's the goal here. You give up encapsulation. You say, look, the API totally reflects the internal state. I have a name field. I have a get name property. I have an age field. I have a get age property. Getter. So The API and the internal state are identical, basically, but you get the API for free. That's the deal here. I give up encapsulation, I give up decoupling of API and internal state, but I get the API for free in exchange. You will most likely be able to customize records. So here, for example, you get the constructor, but what you can do here is you can basically write code that runs after that constructor. So the compiler knows that a constructor takes 2 ints in this case, so we don't have to write that here anymore. The compiler takes these 2 ints and assigns, the constructor. The compiler creates a constructor that takes these 2 ints, assigns them to the fields, and then your code runs. In this case, it checks whether low is actually higher than high. The other way around, whether low is smaller or equal to high, and if it's not, you get this exception. You will most likely be able to sum or override setters to keep this invariance here intact, for example. And yes, this way you will most likely be able to customize records, or let's just say likely. You'll likely be able to customize records. Whether you even want a setter, and whether you always get setters or just sometimes, and which of them by default, how you can configure that, as far as I know, that's still up in the air. Nobody knows anything there. Then this is going to be the start of the end of serialization. Serialization is a really horrible feature. It's not just my opinion. If you look these Ask the Architect talks on the Ask the Architects round that occasionally the JDK team gives to the wider public, for example, at conferences. So people just ask random questions, and Mark Reinhold, Brian Gates, Alex Buckley, those people answer these questions. And then one of the questions that repeatedly says, "Oh, what was the biggest mistake? Or what feature do you wish you never had? Or what causes the most headaches?" And the answer always is serialization. Always. Because it apparently complicates every single JDK feature. Every JDK feature has apparently a part of its budget earmarked for, and this is where we're going to deal with how this screws with serialization. So that's a significant problem there. It was a reason for repeated security vulnerabilities. It uses invisible mechanisms that developers have a hard time to analyze and understand. And JDK team wants to get rid of it. And there might be replacement, or it needs to be replacement, of course, and replacement might be records. So the idea is that you create a new mechanism that only works on records, which is pretty great because records are a great abstraction for this, right? A record says, I'm just my data. And that's the best stuff that you can serialize if it's just its data. Because then you can give this to a general API, which is deconstructs an entire record graph, right? So record knows another record, blah, blah, blah. This entire thing, you throw the API, it deconstructs the entire thing, and it passes the individual bits to a serialization engine. And then you have an engine for XML, for JSON, for YAML, maybe even for the old serialization format. And this way, you can very easily serialize Java classes, Java records into all these formats. As I said, records are a great fit here. The new mechanism uses these deconstructors, makes it much more obvious what's going on. Unlike with serialization, you will more clearly see which fields it takes and why. It will be much more maintainable for the JDK team itself, so this is a win. But this will take ages, which will not be done by Java 12. I wouldn't be surprised. Well, it's not going to happen this decade. 2022, I'm guessing, could be the earliest where we see this. And this is just mostly made up. I'm just saying there's a long path until the old serialization is gone and the new serialization is in place. Then we'll most likely get something like concise method bodies, which is just looks a little crazy, I gotta tell you. Let's say I have a list wrapper here. I have this class that implements a list interface and it wraps another list. So the whole idea here is I delegate each method. You want to know what size I am? I'm just going to call list.size. You want to get this element? I'm just going to call get here. And if you want the index of, then I'm just going to call index of. And since this is the Lambda syntax here, wouldn't it be nice to reuse the method reference syntax? So what you're basically saying is the public method index of an element is the same method as the index of method on this list here. That's kind of neat. If we have a simple method, the code will end up reflecting their simplicity. You will have fewer lines, and you may even have way fewer empty lines. Because methods with a regular body, I would have put a space in between, like most people, like most text, most code stylers do. And this way, this makes it necessary. This is a very concise way to read it if each method has a single line. I'm not sure whether that's worth the mental effort of understanding this new syntax. I think it's kind of neat. I'm not sure whether it carries its own weight, but I'm curious to find out and see more use cases. It's truly interesting change. So Project Ember is really a very impressive project. I think it makes its whole goal is to make Java more expressive. Type inference with var was one of its features, which we saw in Java 10. Raw string literals, not going to be in 12, but then in 13, I guess. Switch expressions, which are already in 12. Pattern matching, which are upcoming, building on switch expressions. Records as well. And then, as I said, revamped civilization, concise method body. So there's a lot that Project Ember has put on the horizon that's going to come out over the next couple of years. Do you have questions about Ember?
Yeah, we have a few questions basically. So, all right, though for string literal, we use the escape sequence, right? So, do you have to do that for these? Uh, can you go to yeah for this new raw string literal?
Sorry, what was the question? Whether you use backticks here or?
Yeah, so since we have used backticks here, what we have, so for the string, in the string literal, we had to do
Yeah.
the skip sequence for the yeah
You mean I've used backtick in here? That's
yeah
actually one of the topics that are being discussed about how this exactly should work. Because I think, as far as I know, the current idea was to have, if you have a backtick in here, let's say this were a backtick, you just use 2 backticks out here.
oh I see
So however many backticks you want to use in sequence within, just use one more on the outside.
I see
Um, that's a really uncommon, un-Java-y flexible way to have this thing. But it doesn't mean it's bad. I'm just saying it's really not something that I'm used to. It would work out in practice, but I think this is one of the reasons why it's not still being discussed, because some people apparently see that with mixed feelings. I guess that's one of the reasons.
all right so one more questions which is the tag which we started with HTML and then end with HTML tag uh, uh, does it align with the end tag as well? I mean,
I mean, like indentation.
yeah, sort of.
Yeah, that's yes, you're drilling into all the beautiful parts here. That's another good question. Yes, there will be methods on this string here. Well, on any string, there will be methods which with you can align the indentation. So you would most likely have, if you want to print this into a file, for example, you wanted this to be properly formatted. You want this to be maybe up here and then have the spaces here, so these are same. But maybe you don't want to put this like whatever 4 spaces in or tab in or whatever. Maybe you want to just strip out the leading spaces. And there will
Okay.
most likely, well, there will be a method on this where you can basically strip the initial indentation. So you could put the backtick back here, and then you get the although I'm not no, I think you don't put the backtick back here, because then you would start a line with a line break.
Right.
Maybe that gets trimmed as well. So there will be a way to make this work, just not yet in my head.
Yeah, so that's what he asked about intonation and space as well. So there is another question which is the record ready for Java 12?
No.
So okay, so that's a no. All right.
Yeah.
Okay. So one more question, which is not related to the Ember but the previous topic, which is since Oracle JDK will provide more frequent updates as we're going to pay for that, right? Can OpenJDK get those updates and add in the OpenJDK as well?
Okay. So the exact release cadence can be different from project to project. So Oracle has this fixed 11.01 and 11.02 in this month's distance from the original release. There's no reason that other companies have to take the same approach. It's just something that might happen so they can align these releases. So it could be that, for example, if Adopt OpenJDK indeed ends up building every night, then you can basically download the JDK 11.0417. I don't know. It should be the build on the 417th day after its initial release. So it's not yet settled which of these projects will release more often. What's more important, though, is where do the changes show up, right? I think that's what he's getting at with the question. Remember that all of these changes pretty soon, almost immediately, show up in the OpenJDK master branch. So they are visible to everybody. It's just a matter of who carries that, who carries that fix and applies it to the old JDK release version. Will
Uh,
somebody do that? And
okay.
the chances are high that Red Hat will do that, supported by the rest of the community. And if that comes to be, then you get the exact same fixes within maybe a week or whatever.
All right, we cannot. I'm not sure Reddit will do that now because since they are acquired by IBM, I don't know.
Oh yeah, oh maybe. Well, and I've heard of no changes from within Red Hat yet, but it's not then. Of course, it's entirely possible that I would just wouldn't hear them. But yeah, I'm not particularly worried. I have to admit, but we'll see. We'll see.
All right. So there is another question. So it's also related to Graal VM. So the question is, why do we have to use Graal VM since we have JVM? Do you know?
Whew. That's a Graal VM question, right? So I know a little bit about Graal,
Okay.
but I learned most of that uh, while watching a talk while I was also checking emails. So this might be totally wrong. So don't play any business decisions. What I'm telling you now. So Graal is not easy to separate. There are two parts of Graal. Graal is mainly a compiler. So within the JDK, an API was created so that the compiler, the just-in-time compiler that the JVM uses, can be plugged in. You can use any compiler you want. Because C2 compiler is kind of like a big behemoth monster, and apparently people would be interested in letting it go and using something else that works better, but more importantly, is implemented in Java, so it's much easier to work with and work on. I mean, imagine C2 is like a 15-year-old C++ code base, which has immense amounts of requirements that it fulfills. So this will be, I think, a fairly complicated code base. So this interface was made so that other compilers, you could plug in other compilers, like Graal. Graal is one compiler that does this. And it uses all kinds of fancy things, and it can be great for compiling JavaScript code and Ruby code all into the same kind of machine executions, and then it gets blazingly fast, and all of that is awesome. So for those talks, I recommend watching Oleg Shelyev's talks on Graal. He's great, full of energy, and he will tell you way more and way more detail about this than I do. But the other thing I want to say, that was about the Graal compiler. He also, of course, talks about the Graal VM. That's a slightly different thing. I'm not exactly sure whether that's just the regular VM with the Graal compiler in it, or whether the VM is different as well. So that's a slightly different piece I'm not sure about. One other thing that you can do with the compiler, you can ahead of time compile stuff. So you can throw your Hello World program at it, and then it just takes 40 seconds on my laptop. And that's not a bad laptop. It's not because of that. So it takes like 40 seconds to spit out a native image, which contains all the JDK code that you need, all the dependencies, maybe if you had any, all your own code, and puts that onto the as a native image out and spews it out on a disk. And there you go. You can run a couple of milliseconds. You can run Java programs then. That's also something that people are interested in.
All
That's
right.
all I can say about Graal.
All right. Thank you.
Sure.
So we don't have any more questions.
Okay, let's go to Valhalla. The goal of Valhalla is to implement advanced Java VM and language feature candidates. That's really vague. What it really is about and where the val comes from, it's about value types. I'm going to talk about that in a second, of course. It was led by Brian Getz and John Rose. Once again, tons of links to talks. Also launched in July 2014, so it's already pushing on 4.5 years. This is taking some time, and it will take some time more because it's a very complicated thing. Well, within the JDK, to us, it's not really that complicated. What we want. The problem here is what Valhalla wants to address is that in Java, almost everything is a class. You have a couple of primitives, but everything else is a class. That means it's mutable unless you fight against it. You have memory access indirection. So if you load a point class, which has X and Y, then you can't just load X and Y from memory. No, you have to load the pointer to point and then go there and then see those integers. So that's X indirection. That header, well, each object has a header that requires more space. So you have a memory layout that has, besides the stuff that you care about, you always have a little stuff in front that you specifically don't care about, but the JVM needs that. And you can do all kinds of crazy identity-based operations like logging and serialization and play tricks with that. And This is not something that you generally want for objects usually. It's just something that Java turned out to do. Would it be nice if we could just create my own custom, something like an int, like a complex number, for example, which is basically a real part in an angle? Or let's just take a point, which has 2 coordinates, or the range we saw earlier, which has a low and a high value. Something that's just like very simple 2 data, basically like, as I said, like my own int. This is what value types will allow. Here I create a value type. I call it use value instead of class. Once again, totally made up. I call it range. And then I create 2 fields, low and high, which are implicitly final. They can never be reassigned. And then I have to write everything else that I need, right? So this is stuff that I write here. I write a constructor and maybe static factories, equals hash code to string accessors, all kind of stuff. This thing has the goal to, wait, does it come up? Yes, here. To code like a class, work like an int, meaning you can use a lot of stuff from classes here. You can implement interfaces, for example. You cannot extend other classes, but you can implement interfaces. You can have methods. This is mostly writes like a regular class, but it behaves like an int. And that means it's immutable. It makes sense to consider the integer new integer 5 and new integer 5. They obviously are equal because they have both the value 5. But these are not the same instances. These instances have an identity beyond their value. This thing and this thing is not the same just because they have the same value. But that's for an int, the int 5 and another int 5, that doesn't make sense. It's still the same int. There is just one int 5. And this is how value types will work. There is just one of these things. So you cannot change that. You cannot change the int 5 to the int 6. You instead of 5, but you don't change the value. So these are always immutable. You don't get any memory indirection. So when there's a range somewhere, then you will see the range there with its 2 fields, not a pointer to some other place. That means the memory layout is flat. Imagine you had a list, and then in that list you had lots of pointers to somewhere else in the memory where all those elements in the list are, right? If you have if you have a list of capital I integer, then you will have all these pointers in there. If you have an int array backing it, then you have just like a flat array full of ints. This is how this will work. You will have the flat memory layout where wherever there is a range, there will immediately be these 2 ints without indirection. You don't get a memory, so you don't get an object header because they have no identity. The JVM doesn't have to track anything specific to them. So they also get denser, meaning you really have int low, int high, int low, int high, int low, int high without any overhead. And once again, this makes Java expressive because now you can clearly communicate to your colleagues, to the JVM, what you want to have. You want to have a value. You don't want to have a class which has identity, which can have inheritance, all that stuff. No, you just want and also as a deal, the deal here is I give up identity, I give up mutability, I also give up self-references, but I'm not going to discuss why. So I give up these things. In exchange, I get a flat and dense memory layout. So this is the trade that I'm doing here. So let's compare this to records because they are similar, and I on purpose use the same class here, range, or the same type, range, in 2 scenarios to show you what the difference and what the similarities are. So they look similar in code, but they do behave differently conceptually and compile runtime. So value, the deal is, I don't need identity, give me a flat and dense memory layout. And with records, the deal is, I don't need encapsulation, take away my boilerplate. And now the question is, how often do we have both of these cases at the same time? I would guess fairly often. I would not be surprised if it turns out that maybe 2/3 of my values actually also should be records or the other way around. And that's why there might most likely be a combination of value records, or whatever you want to call them, where you can basically say, I don't need identity, I don't need mutability, I don't need encapsulation, just like the example of the complex number or the range that I give here. I don't need any of that. I just need 2 values side by side, do all the rest for me, Java, and we'll most likely be able to have something like a value record. So now, everybody runs around and creates their own values. Everybody runs around and creates something that is, in effect, wanted to be properly used like a primitive. What you want to have is do something like this. I now use int here. I could use range here. I could use my own private primitive, basically, that I just created. I do want to have this. I want to have a list that is this primitive type, and that is the array list should actually be backed by an int array. If you could not have generics over primitives, then you would have to box all these value types, just like you need to box primitives now. For primitives, that's bad because it can really ruin your performance. That's why it's bad that it happens there. Here, it's also performance impact, but it's also very unnecessary because we feel like, okay, I know I can stay away from int, but these value types were given to me so I can finally express primitives on a higher level of abstraction, have actually a primitive that consists of two ints and a string maybe. But you have to immediately give it up and have it boxed and have it used, have its performance characteristics destroyed immediately, because you of course want to have a list of ranges. So if everybody creates primitives, then we need to have a way to go around boxing. And the idea is to do something, as I said, something like this, where you can have generics over primitives, but, and that's the really cool part, all the things that in here are a T array, for example, would actually become an int array. So it's backed by an array over the primitive form, not over its boxed form as it is today. That will, of course, lead to great performance and should work value types and all value types. So it gives a performance boost for code that is already, well, if you slightly rewrite it, for code that is out there that uses now collection types, but I will also allow way more uses for these collections, for example, or for generics in general or primitives. To put this together, value types and generic specialization, JDK. For example, at the moment, you have manual specializations of functional interfaces. There are tons of these versions of these interfaces, so you don't have any boxing. The same is true for the Stream API. There's a stream, but there's also an in-stream, I'm not sure. So all these are specialized for these individual primitives, because otherwise you would have all these primitives boxed all the time. So stream over integer is measurably an order of magnitude, only uses ints and never boxes anything. Same is true for optional. So first effect inside the JDKs, hopefully, and that's kind of the goal. The goal is that in stream would basically just have to extend stream of small int, and then it has here that all these manual specializations become absolutely superfluous thanks to generic specialization, and that all this code can be deprecated and eventually be removed. And of course, you get way better performance for these data-intensive tasks.
So that means in the Java util package, we have a few functional interfaces, so we don't need those for primitives. I mean,
yes. So ideally, stuff like toInt function, for example. Well, there are two things. The first one is the hope from the language design point of really toInt function becomes totally unnecessary, because function of int does already exactly the right thing, and toInt function just have entirely possible just like that, because the specialization implement new methods that could work. If the feature turns out optimally, then that should just be trivial. That does not mean that they would actually get removed. That's a different discussion about deprecation and code breaking and stuff. So the removing them is a different discussion. I also want to talk about the effect on your code. For us, that means that we have to make fewer trade-offs between design and performance. I mean, the whole idea behind not optimizing prematurely is that it might screw your design, and you might end up with a suboptimal design but that you made for performance reasons. Then in the worst situation, you didn't even verify that it actually helped you, so you get bad design. So that's not a good place to be in, to have to make this trade-off. And that occasionally happens. Someone profiles you, this stuff just takes too long. We need to be 10% faster in general, and we have to save a lot of time here because that seems unnecessary. Then you might break down a nice OO design into something else, which might maybe uglier because you want it to be faster. So, for example, instead of having a list over a range with int and low, with low and high, maybe you decide to just have two integer arrays and use those for all the low values and all the high values, and then that's something that you could do to get. It's unfortunate because it really destroys the design that was in there. With value types, this becomes unnecessary. There is no trade-off there anymore. You can express that my range or my point is just a value. You get the same performance as if you would have used blank ints, but you get a good abstraction in there. So that's really great. then of course you get the better performance. You can express design APIs more clearly, and I think you can make it more robust as well. For example, if you take some instance, and you later return it, maybe under some situations the caller relies on getting the same instance back, right? That might happen. So they give you a list, and they expect to get the exact same list instance back, something like that. Everything that operates on identity does not work with values. So that's pretty good, actually. You can say, look, my API takes mainly values. That means whatever you give me, it doesn't have an identity anyway. So never mind. There is no, I cannot give you back the same or different instance. So that would make APIs more robust then. So that's what Project Valhalla is all about: value types, primitive specialization. And now it would usually come to Project Loom, but given the time, I'll just do that very, very quickly, unless you have questions about Valhalla first.
Well, we don't have any more questions.
Okay. Then let's go to Loom very quickly. I'm going to skip the technical part. I'm just going to stay with the fluffy conversation-y part. So say you have a web request coming into your application. What happens? The first thing that happens is you interpret the request, take the JSON apart, figure out which methods to call something, and then you end up with a database query. And then later you process the response, process the data, and make up a response and send it back. So during steps 1 and 3, you're using the JVM resources quite well. All the threads are busy, they're doing stuff in memory, that's nice. Step 2, though, you're really just sitting there. So if you take the regular approach, you take a thread per request. That means you can block on certain calls, and during that blocks, you have very bad thread utilization. Well, in general, overall, you have a bad thread utilization because many of them might be sleeping. The other approach is to use an asynchronous programming model where you use non-blocking APIs with futures, but that code is largely incompatible with synchronous code. So if you cannot use synchronous or libraries in an asynchronous world when they start blocking. But you get great thread utilization. So it's a little more complicated, and you have not so many degrees of freedom, but you get great thread utilization. It's very scalable. That's unfortunate. You have to make this decision. Once again, do you want to have a simple model which is easy to debug? I see where all the things are, or do you want to have one of these non-blocking APIs, which work a lot by registering and making it much harder to debug, like a stream API. This above is a for loop, and this down here is a stream API. Imagine which one is easier to debug. That's similar. And then fibers. Fiber is something that looks like a thread to us. We think it's a thread, but there are so few memory that there can be thousands, millions, maybe billions of them. They're very easy to switch, and the JVM will do that. Let's not talk about fiber management. Let's talk about the fiber example here. So the idea is that request comes in, then they go to database, and then they process data for the response. In this fiber, that will look like this. The JVM submits the fiber to a thread pool for the first step. Then the first step gets executed, and when the second step blocks, then the fiber yields, which means the fiber gives back its thread. So the JVM can put that thread into the pool, and the thread pool can do other stuff, right? So the thread is busy now, where the fiber blocks on the call to the database. When a second unblocks, the JVM just picks a new new thread from the thread pool, puts the call stack back together as it was before, and continues. So that means when you debug this code, then you will always be in a thread that blocks on the database, for example. There is no asynchronous API that you're using here, but the JVM in the back just refuses to let a thread or let a fiber block. When the fiber says, I'm calling the database, or give me that thread back, I'm going to reuse it while you're waiting for something. So this is where we get great thread utilization, but code is still written in debug as if it were synchronous. And if this turns out perfectly, then you might just have a small update in stuff like Tomcat and Jetty, and then they can just take your old Java 7 code, for example, and run it on this JVM, and you get fibers instead of, and you suddenly see a way better performance without having to change any line of code except updating your web server. Let's not talk about continuations. Let's focus on Project Loom, which makes trading more pleasant, simple programming model, but great thread utilization. I'm really looking forward to that. So in general, about projects. I recommend pick a project that interests you. If something what I just told you interests you, if you're more into native programming, there's Panama. If you're interested in Graal, there's Metropolis. There's a list somewhere in the slide deck. There's a link to the list of all the JEPs, all these projects. Pick one out that you like or more, and look out for it. Look out for people tweeting about it, making videos about it, giving talks. Right? Maybe even subscribe to the mailing list. There are early access builds for most of these things. Valhalla, for example, there's an early access build. You can already try that and play around with it. And you can use this opportunity to learn a lot about the JVM, but also to give feedback to those people developing it, which they're very thankful for. If we figure out, look, not just theoretical, like I don't like the syntax kind of feedback, but I took this thing that you built and I ran our program on it, right? So I compiled our entire application, and turns out that we do get compile errors. We get compile errors because of switch expressions, something like that. That's valuable feedback to get. And then talk to your colleagues about it. Make this something that I enjoy most. I work a lot from home, but when I go to work, what I enjoy is like talk to colleagues about a thing or some new library on JavaScript or something. There's always something to discuss, and discussing these upcoming Java features is a lot of fun and spreads a lot of knowledge. I was already introduced, so I'm not going to repeat that. You find all the links to my blog and to my YouTube channel and Twitter here. As I said, you can hire me for training on all of these topics in JUnit 5 as well. And the book is out, but I gotta warn you, it's not yet available in the Dead Tree version. There's no paper version yet. It's just electronic. But to make it up, you get 30% discount if you use this code here. So I hope that makes it acceptable. And with that, I'm done. Thank you very much.
All right. Thank you, Nicolai. It was really great presentation, and I learned a lot. I'm sure our audience also learned a lot from you. and yeah, so I cannot thank you enough. Thank you for your time and joining us from all the way over. I mean, we have a really long physical distance, obviously, and then there is a time zone issue.
Yeah.
So
no, but thank you very much for having me. And I gotta say, you guys, you folks are hardcore. Like, are you seriously meeting at 10 in the night? When you have JUG meetings in Germany, they have to be over by 8, or people leave or fall asleep.
We are trying, actually.
Impressed.
Yeah, we're trying our best. Let's see. So thank you again for your effort, and it was really a great session, and we have learned a lot of things. And thank you Parlog, for your time again.
Sure. Oh, and by the way, if people are interested in any links, I'll make a permalink to the slides. I'm sure.
Yeah.
If you want to see a specific slide, give you that.
Okay, sure. You can just send them in email, and I'll put them in the description of this.
Everybody can.
Okay. Thank you, Nicolai. All the best.